Well, recall that in Theorem 3.10, we learned that the continuous image of a compact set is compact. So if you take a compact domain, if you have a compact domain, or if you just choose a compact subset of the domain, we could call it capital D, the subset of the domain, as long as that set is compact, then f of D is also compact. Well, let's look at a couple of graphical examples. Here we've got a continuous function, and D is the union of this interval, and that isolated points, that isolated point. A compact set is closed and bounded, so we typically think of them as either being an interval, a closed interval, or the union of closed intervals, and as well as the union of isolated points. So here's an example, and if we look at the image of this, well, let's see what we want to do. The image from this point to that point is all of the values of the function, or the height of the function between my hands there. So it would look like this, and not from the end point, but the highest point. So if this were, say, capital D1, f of D1 would be this interval right here, whatever those heights are, that interval. Now here, I'm going to have to do the same thing. This one, it's increasing all the way, so it goes from the height, this height to this height. Well, this is already covered, so essentially all we're doing is making it a bigger interval, a bigger closed interval. So if this were capital D1 and capital D2 unioned together, well, f of D1 union D2 would be exactly this one interval. And then this isolated point here would simply be that right there. So as we can see in this example, we have another compact set, a closed interval, maybe unioned together with an isolated point. In this example, we're taking the domain, or capital D, as an open interval, and let's see what happens there. Okay, so I need the height or value of the function, all of the values of the function taken on strictly in between these 2 points here on the x-axis. So, what is the lowest point? The minimum point would be that right there. And even though this point is not part of the graph, this one is, so it's covered. We've got all of the possible heights from here to here covered. Well, what does this look like? It looks like a closed interval, a compact set. So the continuous image of a compact set is compact. It doesn't say that the image has to be compact. We could easily see that if I were to change maybe this D to be right here, where it goes right to the top, then this would be an open ball here. It wouldn't quite reach its maximum value. So one more time, here's an open interval. It's not compact, yet f of this interval gave us a closed and bounded interval, a compact set. Well, recall also that if f maps E into R is a one-to-one function, one-to-one functions have inverses. So f is invertible. And the inverse function, notice the inverse function doesn't go from E into f of E, it goes from f of E back into E. And this could have been replaced, this is the codomain R. I could have replaced it with just f of capital E, and because that's the actual image or range of the function. So the inverse function goes from f of E back to E, the opposite direction. And that inverse function is such that, by definition, f inverse of f of x gives you x. So they're inverse functions of each other. They undo what the other one does. If one of them multiplies x by 3, the other divides it by 3. So multiplying yourself by 3 and dividing yourself, that number by 3, puts you right back where you were. And likewise, if you start an f inverse of y, I used y for being over in this set, f inverse takes you back here, and then applying f to that puts you right back into the same y where you started. Here it is graphically. Here's R. Here's the set E. F is continuous and one-to-one, and it maps all of these numbers into f of E. The inverse function starts at f of E and maps everything back into E. And the question is f of 1, does it have to be continuous? And no, it does not. Must f inverse be continuous? No, but it must be if E is compact. And we'll see that in the next video.